All right, let's talk about a word you use constantly, energy. I mean, we all think we know what it is, right? It's what powers, well, everything. Our phones, our cars, us. But here's the thing. For a word that's so common, it's hiding one of the biggest secrets in all of science. So let's get into it.
So, let's just get right to it. What is energy, really? And I'm not talking about that feeling you get after your morning coffee. I mean, what is the actual fundamental stuff that makes the whole universe tick? You'd think that would be an easy question, but, well, the answer is anything but simple.
Part of the problem is that we throw the word energy around for totally different things. You know, like when we say someone has an energetic personality or we're feeling full of energy. That's all pretty vague, right? It's subjective. But in science, oh, it's something completely different. It's precise. It's a quantity you can actually measure, and this is the big one, it has to follow this one single unbreakable rule.
Okay, so if we really want to get to the bottom of this, we've got to start with a kind of shocking fact. Even the smartest physicists in the world have a tough time giving you a simple definition. Yeah, really. You'd think after all this time they'd have it nailed down, but the truth is, it's just not that straightforward.
I'm not kidding. Look at this. This is from a college physics textbook. It flat out says there's no simple yet accurate scientific definition for energy. How wild is that? So scientists had to change their approach. Instead of getting hung up on what energy is, they focused on something way more useful, what energy does. And this, right here, is where things start to click. See, even if we can't put it in a neat little box and say this is energy, we did figure out its one core behavior. It's the single, incredibly powerful, unbreakable rule that it always obeys. A rule that, no exaggeration, runs the entire universe.
And that rule, it's called the law of conservation of energy. Seriously, if you had to pick just one rule for how the universe works, this would be it. It's behind everything, from how stars are born all the way down to the tiny chemical reactions firing away inside you at this very moment.
The law itself sounds pretty simple, but it's incredibly profound. Here it is. You can't make energy out of thin air. And you can't get rid of it either. It can never be created or destroyed. The total amount of energy in the entire universe has been the same since the Big Bang, and it will always be the same. All it does is change forms. It's like a master of disguise. It goes from being chemical energy in a battery, to light energy in a light bulb, to heat energy that you can feel. And look, this isn't just some nice thought experiment. This is a law that's been tested again and again and again for hundreds of years. It's been proven every single time. And one of the most brilliant early demonstrations of this came from a scientist you might not have heard of, but you definitely should have. Her name was Émilie du Châtelet. She was an absolute powerhouse, a French scientist and mathematician back in the 1700s. And her work was totally foundational to how we think about energy today. And the way she helped prove it, it was with this incredibly clever, super simple experiment. So, here's what she did. She started dropping these heavy lead balls into a patch of soft clay. All she wanted to know was, what's the deal with an object's speed? How does it connect to the amount of work it can do? And in this case, work just meant, how deep of a hole can it make in that clay? And the results were just, whoa, mind-blowing for the time. See, everyone back then pretty much assumed that if you double the speed of something, you double its impact. Makes sense, right? But that's not what she found. Not at all. When she doubled the speed, the ball plunged 4 times deeper. And when she tripled the speed, it went a whopping 9 times deeper. What she discovered was that the energy of a moving object, what we now call kinetic energy, doesn't just go up with its speed. It goes up with the square of its speed. This was a huge, huge deal. It was a massive piece of the puzzle, showing that energy isn't some vague force, but a very specific, measurable, and conserved thing. And ever since her breakthrough, scientists have thrown everything they have at this law. Every new kind of energy they've discovered, chemical, thermal, nuclear, you name it, they've tested it. And guess what? The law has held up every single time. It just plain works for everything. It even applies to the most surprising thing of all, and this was the ultimate confirmation, mass itself. Yep, E equals mc squared. Probably the most famous equation in the world, right? Well, it's basically the ultimate mic drop for energy conservation. What Einstein figured out is that mass is really just a super, super condensed form of energy. You can convert one into the other, but the grand total of all the stuff in the universe, the mass and the energy all added up, never,
ever changes.
Okay, so let's circle back. We started with the problem that we can't really define what energy is, but we know its number one rule. It's always conserved. And knowing that lets us come up with a really practical, really useful definition based on what it lets us do. And that working definition is simply this. Energy is the ability to do work. That's it. It's the juice that makes the universe go. It's the capacity to make change happen, to move something, to heat something, to light something up. It's the power to make anything happen.
But, of course, that just leads to another question, doesn't it? If we say energy is the ability to do work, then we have to ask, what in the world is work?
Well, in physics, work isn't about your job. It has a super specific meaning. Work is what happens when you apply a force to an object and that object actually moves. So if you push a heavy box and it slides across the floor, you've just done work. And the energy, that's the stuff you had to have inside you to be able to push that box in the first place. It's the raw potential to make that movement happen.
Okay, so what? Why is this all so important? Well, because this one fundamental rule, that energy just changes form, it's never lost, is literally the key to understanding, well, everything about our modern world.
You can think of energy as the ultimate currency of civilization. Our entire society is built on our ability to find energy in one form, like in coal or in the sun's rays, and transform it into another form that does useful work for us. This transformation is what drives our economies, builds our social structures, and even shapes global politics. Every single major step forward for humanity has come from getting better at this one thing, changing energy from one form to another. And that leaves us with a pretty powerful idea to chew on. If energy is always conserved, it means the universe isn't running out of it. All the energy we could ever possibly need is already here, all around us. The real challenge, our challenge, is just getting smarter about transforming it. So the big question, the one that's going to define our entire future, is this. If energy is never lost, only transformed, how can we best change it to power our future? Thanks for joining me.